right, good afternoon. See some people still coming in. See some places there, but find your spots. Meanwhile, I'm going to get started. Thank you for coming to this talk, which is called Decomposing Java Applications. And my name is Milen Dyankov. I'm a developer advocate at Liferay. And just out of curiosity, how many of you have heard of Liferay? All right, quite a few people, half of the room actually, not bad. All right, what I'm going to be talking about today is how do we structure or decompose, or whatever word you want to use, Java applications. And this comes from years of experience. As I said, I'm currently developer advocate, but for the last 20-something years, I've been through all the roles of software developer, through consultancy and trainings and all kinds of things. And currently, I'm with Liferay trying to talk to developers about all the stuff that we do at Liferay and how we can help them be more productive with our tools. Now, for those of you who know Liferay from the past years, you may be familiar with Liferay Portal, and you may think that that's the only thing that we do, and that's totally not true, because we these days do have a lot of things in all the spaces like front-end, back-end, services, and all kinds of things. But the experience that I'm going to be sharing with you today, it comes largely from what I call the Liferay platform, which is the foundation for the Liferay portal. And in the past, obviously this was one big monolith. And in the last several years, we've tried to actually split it and provide a platform for building all kinds of services on top of that, and provide pre-ready services for developers to use. So if you, for example, want to use things like, I don't know, DMS, CMS, messaging, blogging, whatever, we have these services ready. But that, how do you split one big monolith into like small applications? And this is hard to explain. When I say to people what we do, like, oh, we have this platform for services, typically they go, oh, you do microservices. No, we don't. It's not microservices. Oh, SOA. No, it's not SOA, right? Because people tend to fall for a word. Like, they need one word that describes it. And that's a problem with that. And the problem with that, I realized, is because I actually start realizing what the problem is when I start looking at my kids. And this is why the second title of this talk is Cleaning and Tidying Children's Rooms. How many of you are parents? All right, half of the room. So you understand what I would say. Like, when you are a parent, when you have your kids, and you try to explain to them why they need to clean their room, what arguments do you use? Like, you tell them, go clean your room, and what they say? Well, it's clean, right? And it's the same thing with software developers. You tell them, you need to do this type of, like, call it, I don't know, DDD or clean architecture or whatever, and they say, but that's what we do. Right, and it is a common misconcept here because we try to describe a huge thing with a common word, and this word means different things for different people. So what I realized works for kids, and actually works for software developers as well, is when you stop trying to put things in one word and actually explain the consequences. The same with your kids. It's not really about the room being clean today. It's about training them to think about how important it is to take care of the room over time, and with not only the room, but all kinds of other things in the future. How many of you are familiar with the Conway's law? Okay, for those of you who are not, it says roughly that an organization that designs a system is inevitably to produce a design structure that is a copy of the organizational communication structure. So I never really quite understood that Conway's law, but what struck me is, well, if that's true, we can actually reverse that. And then we can say that the design of any software system can be represented as an organizational structure. And if you think about it this way, it gives you a nice way to actually give an example of software architecture that are more like easy to comprehend. So this is what we're going to do today. We're going to pretend we don't build software. We're going to build company. Meet Harry. By the way, all the code is on GitHub in case you want to play with it later on, because I'm going to be going through the code really quick. It's not a point for you to read every single line of the code. It's more of a decomposition and structure that I want to show you here. Oh, so meet Harry. Harry wants to start a new business, and he figures out he can do house cleaning. So he bought a van, he has some tools, he has some supplies, and he's gonna have customers who call Harry, say, can you clean my house, here's the money, and he gets the money, and he goes, cleans the house. Okay, how Harry does this? Well, very simple. Here is Harry. He starts with the tools, with the van, and the stuff, and then he has this clean house thing that people call. He checks if they pay him enough. Then he gathers his cleaning tools, he gathers his supplies, he loads it in the van, drives to the place, clean the house, drives back to the office, put the supplies back, and put some income in his booking system. Pretty simple. That's all Harry does. Like, that's his business. But Harry's also a person, and he can, for example, borrow his van to someone. Like, if that someone is a friend, then Harry can borrow the van, and it's not a friend, Harry will say, sorry, but yeah, it doesn't work this way. And the same thing, he can borrow tools. I also have, for all the examples, this thing called client, and client is basically a simple JShell application, not JShell, sorry, shell application that I can use to demonstrate how this works. So let me quickly go to the house cleaning 1 example and run this with Java 8. This second parameter here is which version of Java I use. This is Java 8, and you'll see why that's important later on. So I have this house cleaning example here, and I can say clean house, for example. What happened here? I forgot to change the name, probably. Okay, yeah, because I was fixing the code 5 minutes before I got on stage, obviously. Anyway, so this is the process. Like, Harry goes, cleans the house, it works. Then I can say borrow van, and Harry will say, well, sorry, but I don't know you. Well, I'll say, oh, Harry, I'm your friend. And Harry will borrow the van, and I'm going to get the van go somewhere, and Harry's out of business until I return. So obviously, Harry figures out this is not a sustainable way to do business, right? So what Harry decides to do is to hire, okay, back here. That's the example. Like, everything is Harry. And it's super simple because whatever you want to change, you know where exactly to look. It's Harry, and it's tools, and it's van, and it's one place. And it's super simple, right? It's just not something that can sustain long term, right? If you keep adding stuff to Harry, eventually Harry couldn't handle it all. So he goes to look into how other businesses are structured and figures out he needs to split things, okay? So he has done his survey, and he gets this thing called Smart Garage. And he puts all the stuff in this Smart Garage. And Smart Garage is a thing that allows you to do, like, select from cleaning tools, you know, where. Not that Harry really needs the Smart Garage at this point, but that's what everyone else in the area is doing. So he has this Smart Garage thing. And he also hires Ronald. And Ronald is going to be taking care of customers. And once he gets the order form from the customer, he's going to call Harry, tell him, hey, go clean this house. And that's pretty much it, right? So how does that work? Wait a sec. Clear. So we're going to go now to house cleaning example 2. And again, run this with Java 8. And if I now say clean house, you will see that actually it's the Smart Garage now that tells me what tools I should go and what should I take. It's Ronald that gets the form, right, and thanks me for ordering and so forth. So super cool. But what happens here is that I can say borrow van, and in this case, I don't have to say, am I a friend or not, because who borrows the van for me? Ronald. How that happened? Well, that happened because now because Harry has split stuff, and because Ronald, Harry, and the garage are all in the same place, then Ronald actually has direct access to the garage and the van and the tools. So he can now borrow stuff without Harry even knowing about that thing. And you can imagine this long term, like when more front-end people, more front office people showed in company and more cleaners showed in the company, this becomes a huge problem to maintain because you don't really know who can borrow things to who and in what conditions. So Hari goes like, nah, that's not going to work that way. I'm going to need to figure out a better way to structure my company. And so he looks for the best practices in the industry, and he decides to divide this company in the following way. So he has the assets. So this thing that he puts all the stuff in it, right? And in this case, he has the garage. Well, smart or not, doesn't matter. With the van and storage for the tools. And so he also has the company here, which is where Hari basically is, because he is the company. And he also hired Andrei to help him. So Andrei is an assistant, and Hari can say, give me the tools, and Andrei is going to prepare what needs for him. Right? And then he also has a front office, which is where the order form and Ronald are. So let's see how that works in a real life. Big screen here. We're going to go to house cleaning example 3, and we're going to run that again with Java 9. So if I say clean house, yeah, Ronald picks up the form again. Andrei prepares the tool. Hari does the cleaning, drives the van. Andrei puts the tools back. Yeah, it's all good. Can we still borrow the van though? Or borrow the tools? Sure, we can. Why? Because if you look at now at what is Ronald actually doing in here, Ronald is just getting back to the garage. And he can still go about, ignore Hari and ignore everyone else. He cannot go to Andrei, though, because Hari was smart enough to say that Andrei is isolated in his own package or building or whatever you want to call it. So calling Andrei directly would not work, but what's the purpose of that if Ronald can still go to the garage directly and get the stuff out of there? So this is this example. So we have a module, we want to call it module, it's front thing, where Ronald and the form are. Hari and Andrei, who is hidden, no one can access it, but Hari can work with him. And then you have the assets stuff in the garage and in the storage. The problem with that approach is because still the garage and the storage needs to be available for Hari, they also automatically available for Ronald. So he can just pass by Hari and go grab stuff for himself. What you see here is what I call the ultimate BBC architecture, which stands for box, box, cylinder. And I bet most of you have been building applications in this way for the last, if you've been long enough in the industry, this was the universal standard. This was what we were told that we should build applications like box, box, cylinder. We don't call them that, though. We call them front-end business logic database, or whichever names you want to choose for the box and the cylinder. But that's ultimately how we used to build applications. And this is what 2 years ago the industry decided it's bad. So we switched to something else, and this is what obviously Hari did. So Hari said, nah, that's not going to work this way. Let's try something different now. So now we have the back office. And in the back office, we have the storage and Andrei, who's going to take care of the back office. And storage is not going to be available to anyone. It's package private. But Andrei is the one that handles all the things. So whatever you want to get something from the storage, call Andrei. So then you have the clients that are important in here. You have the company, which is Hari in his garage kind of thing, with pretty much the same logic. And then you have the front office, where is Ronald. Well, now Ronald can no longer access the garage directly, as you can see here, because it's hidden now from him. But he can access Hari, and he can access Andrei. So let's try this example, just to make sure all works. Okay. So house cleaning 4 now. Run again with Java 8. So just to make sure this thing works, cleans the house. Sure, example works as expected. Borrow van. Oops, I'm sorry, I can't borrow the van because now the only way to borrow the van is to go through Harry, and Harry needs to know if you're friend. But if I say borrow tools, here we go, he can still borrow tools. Why? Because he went through Andrei, and Andrei wasn't aware of that fact. That's the architecture you see in here as the client, then Ronald and the front office, and the company module in between, and then the back office in there with Andrei. So now you have the logic in Harry. Harry says, well, I'm not going to borrow my van to anyone I don't know. But Andrei doesn't know anything about that stuff. So whenever Ronald says, borrow me the tools, here you go. So that's another problem in here, which is a common problem in what I call the universal microservices architecture. In this particular case, you just have a separate isolated boxes, and you throw stuff in these boxes, like your database, your Docker container, your Java virtual machine. You just put stuff in this box, and then you pretend it's micro. And then you end up in a situation where you have like thousands of those, and they all need to talk to every single other one, right? And management of this becomes somewhat complicated. So Harry looks for something better than that, and he goes like, okay, let's do different things here. So in this example, we have a thing called company. And in the company, we now Harry figures out that, well, it's no longer about my storage and about me and about my van, but it's about my company and the processes that are inside the company. So the processes and how the company functions is far more important than the assets, the entities, if you want to call them this way. So he structures it in a bit different way. He now says the company has assets, and this is like software, storage, vehicles, whatever. It also has job positions, right? That's what you have in the companies. In the proper companies, you have job positions. So there's an accountant, assistant, and those are definitions. They don't do nothing by themselves. They just describe what someone in that position is supposed to do. In Java world, we call those interfaces. And then you have processes. Like, for example, you have a clean house process, which is super simple process as get the cleaner and tell him to clean the house. Or you have the transport process, which basically says get the van, load the stuff, go to some place. So you have a bunch of processes in there. You have some shared stuff in here also, because you need to communicate internally in the company. You need to say, yeah, they paid enough money, or no, they didn't. So you got some like error handling stuff here, and all kinds of shared things in it. And then you have stuff. You have the actual people, and if you look, for example, at Andrei, he's an assistant. You look at Harry, he's both cleaner and accountant. Yeah, well, why not? And then Ronald is basically a person. So this is the internal structure of the company. But do the customers need to know about that? Of course not. They don't care about that. The only thing the customers care about is how they can actually make use of that company. Or, in other words, what is that the company provides for them. So we call these things use cases. This is how you use the company. And in use cases, it's, let's say, customer use case. We just have for now one use case that says it's clean customer house. And the clean customer house get a cleaning request as an input, and then it knows about the processes. So here are the 4 processes that we've defined internally in the company. And he goes through them, say, hey, new order process, check the payment, and then new order process, prepare me some cleaning instructions, and then prepare for cleaning process, prepare all the stuff. Transport process, get me there, and clean house process, get the house clean. So now, from the front office perspective, the only thing that we can actually do here is get the, where it is? No, that's the request, sorry, wrong file. So we just get the cleaning request, and we use the customer use case. and basically say, oh, that's the service that company provides, so that's the service we want. And if you think in real life, that's how business works. You say, that's what I want from you, and I don't really care how you're organized internally, right? So let's try that. Exit this one, clean the screen. We're gonna go to house cleaning 5. And we're gonna run this with Java 8 again. So if I now say clean house, oh yeah, and I changed the code a little bit, so we now have to say which currency we use. So it's like for €100. Here goes. You will see that, again, Ronald, Andre, all they do their stuff, but what we deal with is not them personally, but the processes itself. And if I say, well, you know what, clean my house for €1, then you will see that the process goes again, and Ronald checks the payment, and then the front office tells you, no, sorry, €1 is not enough, we charge more for that, right? But can we still borrow the van? That's the main problem here. Sure we can. And can we still borrow the tools? Well, sure we can. Even though we've established like company and processes and stuff, there is still an option for the front office to go straight to our back office, or where the company has asset, because all these things, they cannot be hidden now because they're in separate packages. So if you go to vCos and say, nah, I don't want you to access this, well, front office will not be able to access it, but so will all the other processes in the company, which you don't want to happen. So this is this. So you basically have split the company into like what we call company here, which internally is divided into things that make sense for that company. Then you have the use cases. Now, why is this a little bit better? Because now you acknowledge the fact that in the future, you may actually have different use cases. You may provide clean backyard use case, or clean, I don't know, pool use case, or whatever. Your company is free to evolve with the same resources that it has, or by adding or modifying them a little bit more, but you just can provide the different use cases with the same company. And on the front end side, you are now not limited to having a front office, but you can also accept customers through different channel, like RESTful services, for example. So this works, but still, the front office can go through all this, use cases and stuff, and access company directly. And long term, when you get more people, they're going to get smart, and they're going to start do stuff like this, and then you're going to get in trouble. So maybe it's time to fix that as well. So here goes the next example, which is code-wise exactly the same as the example 5. The only difference is that we now have this file called module info in here. Company source module info, that's one. Which now says, well, we export these packages. So this is what's available outside of the company: job positions, processes, and shared thing. But then to make this work, internally, we have these packages in here, and we also have this internal package with stuff that we don't export. So this is our company stuff that we don't want anyone to deal with, right? Other than that, it's pretty much the same code. So how this works? Okay. If I go house cleaning 6 and compile this, let me now compile it actually, nvn clean package with Java 8. This is no different than what we had before. This file makes no difference. Let's run this with Java 8, and then we just say borrow van, and you will see it works. Okay, but now let me build that thing again with Java 9. And if I try to build this with Java 9, what's going to happen is big red errors. And the big red arrows comes from what is new in Java 9, which is the JPMS, the Java Platform Modular System. And this is what is defined in here. What stuff we export, and basically it tells you, you're trying to access internal assets, which is defined in the company, but it's not visible for you. So sorry, you can't do that. So as you can see, you can't even compile the thing, let alone run it. So we need to fix this, and the only way to fix this is to actually go to the front office and tell them and make them not do the things they are not supposed to do, which is accessing directly stuff that they shouldn't be accessing at all. So for now on, they're only going to be able to say, sorry, we don't support that. Because Java 9, it's in the early days, it doesn't really know that when you import stuff, you don't necessarily have to use it. So you also have to comment out the imports. So let's build that with Java 9 again. And you will see this is going to now compile just fine. Now, if I try to run this with Java 8, it's not going to let me, because it's going to say, well, your project's now modular, and sorry for that. You compile it with a new version of Java. So I have to run it with Java 9 on the modular path. And when I do that, I can now say clean house for €100. Here goes. And I can say, borrow the tools. Oops, sorry, we don't support that. Now, that's exactly what we wanted to do, and it took us like 6 iterations to get there. And we had to change Java version, but we'll get back to that in a second. But now, there is another interesting thing. If we go to the company process, the company processes in transport process, there is an interesting method there says is Vanc functional. And this is where we realize that while we do our business, our Vanc can break, right? And if it breaks, well, what happens, right? This just uses the property files to demonstrate the purpose. So let me go, this is 6, where's the properties files? It's called status, here we go. So let me go get here again. So I'm now just going to say, our van broke. Here we go. And please clean the house. A customer comes. Clean the house. Boom. It doesn't work anymore because our transport process is broken. So what do we do now? Well, company shuts down until they fix the van. I mean, you all know this is not how company operates. They have backup plans for this, like that, for things like that. So we need to fix that in a different way. And a different way is we need to acknowledge the fact that everything inside the company, and which example I was showing you here. So that's example that we had. We used the Java Platform Modular System to make those packages that are internal for the company not visible to the people that don't need to visit, don't need to see them, right? But now we have different types of problems. Well, we have the same. We used to have this problem before. It was just not that important. Now it is important. What happens if the van breaks? So how do we fix that? Well, we introduced things that are well known since Java 6, and not a lot of people are aware of them, called services. And service loader. How many of you are familiar with service loader? That's what I figured. That's typically the amount of hands that like less than 5% of people who know what service loader is, even though it's been available since the Java 6. What's the difference? The difference is that now we've split our processes into 2. External processes, which are nothing but a process definitions. So now we have, if you are a transport process, you need to be able to get me from this place to somewhere else. And then inside the company, we have a real process that says is a transport process that is a transport process, and that actually tells you how. Right? So one is a definition, the other one tells you how. And then what also we have, with this, we can do things like, now in Java 9 and JPMS, you have to do this in module info. In previous versions, there is a different way to define those, but you can still do that. So you can now say, well, this company thing provides a transport process with internal transport process. So that's basically, you're saying that's the implementation of that thing, right? And how that helps? It helps because you can now have another module, say Uber transport. You go to Uber, sign a contract with them, say, if my van breaks, you guys go grab me and drive me there. And then in the Uber transport thing, you can say, well, we also provide the transport process, but within a Uber transport process, right? So we do that with 7. Now, unfortunately, with Java 9 and JPMS, and Java 10, by the way, I can compile this with Java 10, is the same result. You need to know what modules you want to start up front. You can't load modules dynamically. So when you start your application, you have to go and you have to tell, by the way, I also want to start the Uber process in here. Otherwise, it makes no sense. So let's now exit this. Go to house cleaning 7. OK. And in here, I'm going to compile this again with Java 9, just so to show you that it's real code. And then I'm going to run it with Java 9 modular system. And then I can say, clean the house. Hey, it works fine. So my van just broke. And customer says, clean the house. And oops, you go. Just use Uber this time, right? We got a Uber van. We go there. We clean the stuff. And then, well, they just fix the van. And then if I say clean, and then we can still use our own van, right? So it's approaching this from a services perspective, decouples you from the actual implementation and tells you, well, you know what? It's important to be able to do this thing. It's not important how. So in terms of diagrams, this is what actually happens. You now have this abstract services things, and you have other implementations of that services, and basically you don't go grab an implementation, but you basically say, give me an implementation of that particular service, and because they're bound by a contract in the form of an interface, you're sure that they will still do the work that you want it to do. The thing with that is that for this to work, you need Java 9 and 10, or anything newer than 9. You can't really do that with previous Java versions. Moreover, you can't do this dynamically. You have to still know upfront, when you start the thing, what modules need to be there. So there is a different approach to that allows you to do this thing with even Java 8. And it's called Osgi. And I know now half of you are scared, like, oh my god. But I just wanted to show you how hard it is to do stuff with Osgi. So it's very much the same code. We still have the internal processes and exposed processes and stuff like that. So if we look into the internal, we don't have module info in this at all, right? So what we have as an internal transport process is we say it's an Osgi component, whatever that means. And also, if you look into the packages now, for example, the process, we have package info, and which says we export this package at version 1.0.0. Now, that's a scary concept for people who don't know Osgi, because, oh, wait a minute, you versioning packages? Yes. And the reason for that is because Osgi is not importing modules like Java 9 and JPMS does, but is importing packages. It doesn't really care which module the package comes from. It knows that it needs this package, and whichever module provides it, it's totally fine, which gives you a lot of more flexibility than JPMS. But that's a different story. And if you look into the internal stuff here, like our internal processes, well, they don't export these packages. So we don't have modular info, we just have a bunch of annotations. Now, from use case perspective, in here, we have customer use cases. How do we reference processes? Well, with @reference annotation. Now, for those of you who are scared of annotations, those are compile time annotations. Those are compile time retention. You don't see them at runtime at all, and they don't introduce any extra dependencies in your code. So this is just for the building tools to figure out how to wire things. And that's pretty much it. Then you have to do two more things in here, because we are using this things. This is where all the van and the tools and the stuff comes from. And it's not an OSGI bundle, so we need to figure out how to make it an OSGI bundle. And making something an OSGI bundle is as simple as wrapping it in a project, which we use it as a dependency, and then we use this BND file and basically says, well, from this dependency, this is what I want you to export. Then that's it, making it a bundle. And now we need to figure out what to run. Right? And for this, we have another project here, which is going to build us a single executable jar file. And in this case, we have all the dependencies in here, basically says, and use those to figure out which of them are needed. Those are not really actual dependencies as you can know them from Maven, but basically telling the tooling, use those to figure out which of them are needed. And then you basically say, well, I want to run house cleaning client and the shell, and the commands on the shell. And that's pretty much it. I want these 3 modules, and you go figure out which other modules are needed. So if I go now to house cleaning 8, okay, don't help me with that. And I can now compile this thing with Java 8, and it should compile totally fine. Here it goes. And then I can run this thing again with Java 8. And I'm going to have a little bit of a different shell here, because it's GoGo shell, which is basically a different variation of the same shell I was using before. So in here, I can say clean house, provide some euros, let's say 100. And you see the process works the same. Now, what's going to happen if my van breaks? Let's break the van. What happened? Here we go. Save, right. So clean the house for 100 years. Oops, my van just broke. Right, and I don't have Uber. I haven't signed a contract with them yet. Oh well. What I can do now is I can just say install, and I can go to my Uber transport module and get this jar file from there, and say install. Now I can look in what modules I have inside. Oh, I have this module Uber something, but it's not started. Let's start it. And do I have the modules? Yes, I do have a Uber transport module. So what's going to happen now if the client says, okay, let's clean it so you can see it better. So will the customer now say, clean house? Here you go. We go with Uber. I didn't even have to restart my application to do that. And if they fix my van, I can go back, where it is, and just use my van again. So not only I can now run this with Java 8, which probably it's not going to be that relevant in several years from now, but it also allows me to dynamically adapt when the environment changes without actually having to restart things. Now, one important thing about OSGI, and this is where all people get confused, is all this package managing and versioning, and why the hell, what is it with versioning packages? Okay, let me try to explain that real quick. So let's go back to the company and to this transport process. So if you look at the transport process, it has this weird annotation, says provider type. Again, that's a compile time annotation. What does it mean? Well, if you think about transport process, it's an interface that has two purposes. One purpose is to be implemented by whoever provides the actual service, and the other purpose is to be used by someone who wants to go somewhere. Right? Now, if that is the case, this we typically say this is a provider type. It's meant to be for a provider. Now, what's the difference? Because we use semantic versioning, and if you look into the package info of this, wait a second, here, we said this package has a version of 1.1.0, and this is a semantic versioning. Now, the question is, if we change the interface, what version we should put here? In most cases, this is where all the people get it wrong because they try to figure it out. In OSGI, we have this BND stuff that actually tells us how the thing should be done. So let me just quickly demonstrate this for you. I'm going to go to now my transport process, and I'm going to say, well, from now on, we also want to have this status thing in the process, right? Okay, this is immediately going to break my implementation here, which I'm going to realize that internal process also needs to change. So let's do that. Now, because I've already released a version of this, I need to go to my POM file, and I say, I'm just going to release version 0.0.2 snapshot, whatever. I'm going to my POM. And now I'm going to go and try to compile this. Wait a second. Here we go. And I'm just going to go and compile this. And what you will see happening in here is that my company failed. And when it failed to compile. And what it says is, well, we discovered a minor change, but you trying to do a fixed pack change, right? And that's why you can't do this. Oh, and by the way, also, your package, that's your package, like it need to go from 1.0.0 to 1.1, because this is a minor change. Adding a method into a provider type is a minor change. You can't just do fixed pack change. And also, it has the bundle now, it's too low. It needs to be at least 0.1. Okay, I got it. Let's fix that. So now, I'm going to fix my bundle to actually be 0.1, and I'm going to also fix my package here, not this one, processes, package info, to actually be what it says it has to be, which is this one, right? And, no, don't switch to that anymore. And then, come on. Then if I compile this again, it's going to tell me, now it's all good. Your versions are fine. So this is what actually we do use internally in LifeRay to enforce semantic versioning for all the modules that we do, and to ensure backward compatibility on different levels. So it's on the CI tool. Even if a developer does a change, CI tool will not let it pass unless it's properly versioned. And while now, if I want to run this though, this is my run thing here, where it is. And in the POM, I still run this with the old company, right? So I want to run this with the new company. So I'm just going to add my company here as a dependency. And now let's build that again. And just to understand, like, why we are bothering with all this stuff, because it's so complex, right? It's not needed at all. Well, let's run it again. If I didn't make any mistake, it should run now fine with Java 8. Let's bundles. Okay, so now you see that even though all the modules are at version 0.0.1, the company is 0.1.0, right? We started with a new version. And if you look into our use cases, let's go look inside the use cases module, which I can do Or I can just show you here a bundle which it is 5. Well, you will see that it has imports, house cleaning. There was a better way to do this. I forgot the command now. House cleaning company processes, add version 0, whatever, import, find it. Okay, so in here it is. It uses a package, processes, at version between 1.0 to 2. So basically, from consumer perspective, any version between 1.0 and 2 is fine because this is a minor change, right? And that's why we could upgrade our module here to a different version, and our use case module will still function totally okay because it knows whichever version in here is between 1.0 and 2, it's totally fine. Now let's do what I did before, because I restarted it. We don't have the clean house Uber thing, and let's do the same thing that we had before. So I'm just gonna say install and grab the Uber kind of thing here, and it installs fine. It says it's installed. Well, let's now start it. Start 12. Boom, it doesn't. Why? Because it says, well, I depend on a package version that is between 1.0.0 and less than 1.1.0. Why is that? Because when the change that we introduced in that interface broke the producer. If every time you produce a change that someone needs to implement that deliver the functionality, it breaks the producer, but it doesn't break the consumer. The consumer can still use the old version of it. They can still use the interface. They just don't gonna get to call the new functionality that was introduced by a minor change. Now, if you rename a method, for example, or add an attribute, parameters, or whatever, then it's a major change. Then you break both. You break both the provider and the consumer. And then all the consumers will also need to update. So that's one great thing that OSGI gives you, is to reason about when I change things, who I'm breaking. Am I just breaking the providers, which is fairly limited amount, like in this case, it's just one module that delivers Uber transport, or am I breaking everyone out there and asking all my clients to change their interfaces? And this with BND is built in a build process, and it basically says, no, don't do that, because then everyone else out there has to go and change. Okay, that's pretty much all the examples I have for today. What I was trying to do is to avoid one-word description of things, and just to show you, give you an examples of why, in which use cases some things are important and why they are important. Because every time we use, like, you know, the famous saying that there are 2 hard things in computer science, cache invalidation, naming things, and off by 1 error. Well, I believe the most important is naming things. And I think that's one of the biggest mistakes in the industry in the last decade, is that we struggle to name things. We struggle to coin a name for something. And the moment you coin a name for something, what happens is a bunch of people somewhere gather and say, we do, let's pick one, agile. Wrong one. Well, wait, never mind. Let's go with agile. Like, so few people got together and figure out a way to solve a particular problem years ago. And these days, you have an agile experts all over the place that's going to come to you and tell you, no, that's not agile. That's not how you do it. That's how you do it. And then some other person is going to tell you, no, that's not agile. That's agile. And then we argue, keep arguing about, is that DDD? Is that agile? Is that microservices? No, it's not, because don't use Spring Boot. Come on. We argue about stupid things, where we should approach this as we teach our kids to clean their rooms. Do we argue, why did you put this toy here and not there? Now, is it not clean if the toy is in a different place? No, the idea is to tell the kid, to give them the habit to clean things. And why is that? Because if they learn to keep their room tidy and clean, it is a safe and livable place for them. Tomorrow things will change, they will grow, they will have to do math or whatever, and then they're still going to have the habit to check out if this is a comfortable place for me to live and is it safe for me, right? And this is the same with software, and in particular with Java applications and decomposition of Java applications. Even the best Java app that you create today, one day is going to get dirty and ugly. And it's about having the habit to keep it safe, to keep your code, your Java apps, safe and livable place. Thank you.